Alright, in this video we are looking at pages 3 and 4 of the math portion of your final exam study guide. So we're looking at another one of these exponential growth problems like we had on page 2. So annual growth is 6.8%, that's my rate. The investment amount, that's my A. 6 years, that's my time. So I don't know the final amount. So we'll go with 8,500. Right, 8,500 times 1 plus 0.068, and then the time is 6 years. You put all that in your calculator, should get 12,613 and 81 cents. So those are just a matter of getting the numbers in the right spots. Okay, an exponential equation has a form of y equals ab to the x, and I know you can't see the colors on yours because this came out black and white obviously. But this blue one is definitely a steeper curve than the red one. So you can tell the difference here. One's flatter than the other, one's steeper than the other. So where in the equation would you look for that steepness? So it depends on what we multiply by, how fast it goes up. The more we multiply by, the faster it's going to go up. So we want to say that first off, b is the multiplier. And I know that because it has the exponent, so that's what's going to make it repeat. And the larger b is going to equal the steeper graph. And that's because we're multiplying by more. And then the smaller b is going to be the flatter graph. It's going to increase more slowly because we're multiplying by less. So that's how you can tell which one's which. All right, number 11 has 3 parts to it. They're all going to work the same. So I want to simplify first and then use logs to solve. So hopefully you can recall back to when we were doing logs. You have to find the part with the exponent, and you have to get that part by itself. That's the way you set up for the simplify step. So I need to decide how to undo this part around this yellow section, and I need to do the thing farthest away first. So I need to subtract 72 and rewrite it. So it's 4 times 5 to the x. 106 minus 72 is 34. Then I need to divide the 4 so that the 5 will be by itself. And 34 divided by 4 is 8.5. And now I need to know what power to put on 5 to get 8.5. And I don't know, because 5 squared is 25 and 5 to the first is 5, so it's not a whole number. So the way I solve this is with logs. So the first thing I do is put a log on both sides. Then I bring the exponent down in front. And then I divide by the log, the one that's next to x. Alright, so then x is going to equal log 8.5, and I need to use parentheses here, because I'm going to go to the calculator next, and then you need to close it off before you type the second log, and log 5. So when you go to type it, you're going to type log, it'll open parentheses automatically. Make sure you close them when you're done typing the 8.5. You also can hit your fraction bar first, and then it won't matter if you use the parentheses, but if you are not using your fraction bar, you have to make sure you do that. This is always going to equal a decimal. Well, not always, but most of the time. And this comes out to 1.33. So what that means is if I raise 5 to the 1.33 power, I'll get approximately 8.5. And I say approximately because it was a rounded answer. All right, same thing for number 8. First thing is to move the 20, so I need to add it this time. So that means 8 times 9 to the x equals 72. So if I divide by 8, I get 9 to the x equals 9. I could log both sides, but I already know, because this is technically 9 to the first. Well, and the only way for this equation to be true is if x also equals 1. So that one doesn't really require any more work. Now if this was any number other than 9, then I would do the same thing. I'd put a log on both sides, bring the x in front, and solve it that way. But because it was this way, and they matched, I can just match them up. All right, last one in this section, subtract 6 first. Then I want to divide the 7. And that's not going to be exact, so this will be rounded already here. It's 2.29. And then we need to log both sides. Bring the x in front. Okay, we'll divide both sides by log 12. So it's not about which log is bigger, it's about which log is next to x. That's the one you want to divide by to get the x by itself. So x equals log 2.29 in parentheses divided by log 12. And that comes out to 0.33. All right, so those are 3 examples of how to solve an equation using logs. Well, solve a missing exponent. Sometimes you don't need a log. All right, next page, page 4. So we have a screenshot of a Desmos graph, and it looks like some data was plotted first, and then a curve was fitted to the data to see if we can approximate it. Over here, we see what kind of equation was written, which looks like exponential. There's no parentheses here, but b would be the multiplier, a would be the starting amount, and then it tells us what a and b are equal to. Usually we would do 2 decimal places, so this would be 2.98, and this would be 1.08, and then those would go into the equation to write it. All right, so what does a stand for here? So in any exponential equation, a is going to be the starting value. So for this one, it means that the starting value is 2.98. And I don't think we have context here. No, we don't have context here for what this problem's about. So I can't say $2.98, although that's probably what it is, since these graphs are usually about finance. Part B, or the B of the equation, is the multiplier. So multiplier is 1.08. And again, I know it's the multiplier because it has an exponent on it. And that indicates an 8% growth rate. And the reason I know that is because this must have been 1 plus 0.08. Okay, and then R, so that's the statistics feature here, and because it's close to 1, this goes on a scale from 0 to 1. Because it's close to 1, the curve is a good fit for the data. Okay, so that R value is always going to tell us how close to the actual data the trend line is, how reliable it is. All right, number 13, Megan receives a $10,000 gift from her grandmother. She decides she'll invest it with a goal. So that means this is the Y, because that's the goal, with a goal of putting $60,000 down. All right, so let's see what that means. We have a goal of $60,000. We have a starting amount of $10,000. Write and solve an exponential equation. So we need to put this rate in, 1 plus 0.06. And how long will it take? Okay, so I don't know t. All right, well, we can solve this because we know that if we can get the base isolated, then we can use a log. So what I want to do here is divide the 10,000. And that means it's 6 equals. I'm also going to add this yellow part, so 1.06 to the t power. So if I log both sides then, the t will come down in front, and I'm going to write it up here. So it'll be log 6 equals t log 1.06. So divide by the log that's next to the variable. Type it up carefully, use parentheses so we don't get that confused. And it turns out that t equals 30.75 years. That's how long it will take for the 10,000 to turn into 60,000. All right, number 14. We have another one where we have a starting amount and then a goal. So that means that the goal needs to go in the y, and the starting amount needs to go after the equal sign. And then we'll do the rest of our magic here. So 1 plus the rate, which is 8.5%, so that's 0.085. Don't know the time. Going to divide by 8,000. And that's 2.5. And this is, if I add this up, it's 1.085 to the t power. Same process as the last problem now. Log 2.5 equals log 1.085 to the t power. Bring the t in front, so it's log 2.5 equals t log 1.085. And then, if I divide by the part next to t, it'll be log 2.5 over log 1.085. Turns out t comes out to 11.23 years. All right, so hopefully that helps you with pages 3 and 4, and that'll do it for this section.